Hey everybody, today I want to talk about how calcium oxalate stones form inside the body. I came across a study recently that was investigating how actually calcium oxalate stones can dissolve inside the kidney, because the current assumption of most medical professionals is that calcium oxalate stones cannot dissolve. That is not the case, and this study uncovered it. But the main purpose that I want to take into consideration today is how does this stone form, not only from a standpoint of educating you on how that actually happens, but how can we utilize this knowledge to our advantage to stop stones from forming. So today what we're going to do is we are going to go through the entire sequence of events here. There's only 6 sequences, so bear with me here. And again, forgive my crude drawings here, but try to explain at each step of the process of calcium oxalate stone formation and what are some of the things that we can do to combat this, to try to help stop these stones from forming in the first place. So let's take a look at sequence of events 1, SE1, right up here. So in this situation, we have free-floating particles of calcium oxalate monohydrate and calcium oxalate dihydrate. Now, it's important to note that there is a distinction when it comes to calcium oxalate stones. I talk to people all the time, and not even medical professionals are talking about the differences between these two types of stones. But it's critically important to understand these two types because they are very different. Calcium oxalate monohydrate, in this instance, is represented by a couple different colors here, but calcium oxalate monohydrate is very, very dense. Now, this is the most common type of stone that we find in the United States. About 80% of the stones that are out there are calcium oxalate monohydrate. These are kind of cylindrical or circular in nature, sometimes kind of oval shaped like a teardrop even, and they're very, very hard and they're dark. Contrast this to calcium oxalate dihydrate, which is kind of pale yellow in color, has kind of a flat bottom to it, and it's very spiky type of protrusions. You know, kind of looks like a hedgehog if it was laying down on the ground and it's kind of spikes all over the place. That's a calcium oxalate dihydrate stone. And those stones are much less dense and have a higher degree of propensity to dissolve, not only in the body, but also while passing. So it's very important to note these two distinctions. But calcium oxalate stones, they all start with a calcium oxalate dihydrate nucleus, or nidus, the cortex of it, the center. So as you can see here, this particular crystal, we'll call it a crystal aggregate of dihydrate, has grown inside these kidney calyx and pelvis. And this is important. We'll talk about this in a second. But this is all free floating around. It's not up against a wall. So this larger crystal here of calcium oxalate dihydrate is what basically acts like a magnet for all the other free-floating particles in your urine. Now, important to note, you can ask yourself, why are all these free particles of calcium oxalate monohydrate and dihydrate floating around in my urine? This is what we call urine supersaturation. So we have to think about it like if you're putting sugar or salt into a water solution, and if you put just enough in, you won't have any of those little particles that float to the bottom or floating around inside the water. However, when you put too much in and you start to see those crystals at the bottom of the glass or floating around there loose if you stirred it, this is supersaturation. That solution cannot absorb any more of the materials that you're putting into it. And that is where we have kidney stones, especially calcium oxalate stones, start to develop. It cannot develop without urine supersaturation. So when we know this, this is one of the things that we need to start attacking when we take a look at why does this kidney stone continue to form. Now, some things that we can do to try to combat this is we can, in this instance with calcium oxalate stones, we can limit the amount of oxalate containing foods that we have. This will mostly solve this problem for most people. We can ingest more calcium, and we can also increase our hydration to increase the rate at which these type of particles that are supersaturated are passing through our urine, and we don't give them time to aggregate and form crystals. This is also why a lot of people say don't hold in your urine. Don't. Don't allow crystallization to happen. Move this stuff out of the system. Anyways, I digress. So as we move on into sequence of events 2, we can start to see that this dihydrate aggregate is starting to grow because all these little particles are starting to glom onto this dihydrate crystal. Now, at first, it's more dihydrate that starts to glom onto itself. But as we'll move over into sequence of events 3, we can start to see, and again, crude drawing here, all these little pock marks. This dihydrate nidus is starting to get eroded by the much more dense calcium oxalate monohydrate crystals that are floating around in our urine as well. So when we start to come down here into sequence of events 4, you can start to see the banding effect that occurs because the calcium oxalate is starting to chip away at that dihydrate core, and they start to get embedded into this dihydrate core. And then on top of that, the monohydrate crystals basically just pile on and they start to layer, just like if you think about, if you've ever seen a crystal, like a rock crystal cut in half, and you see all those concentric rings and layers, this is exactly the same thing. There is no difference. These layers form over time with calcium oxalate monohydrate stones, and they just ring, ring, ring. Now, another curious thing that this study pointed out that I find fascinating is when we take a look at the shape of a calcium oxalate monohydrate stone, it's that circular, kind of like a ball shape, or maybe it's even like that teardrop shape or an oval. This is due to the way that it forms, because this type of stone forms in that calyx or in the pelvis of the kidney, and it's just floating around. Like all these particles are happening in suspension in the urine itself. Versus some other stone types that form elsewhere in the kidneys and they're bumped up against a surface and they have a different shape. So calcium oxalate monohydrate stones have their shape because of where they're formed in the body. Versus a, let's say it was a true calcium oxalate dihydrate stone that forms elsewhere in the kidney, a little bit further out into the kidney. It has a flat back to it, and then those spiky surfaces are where all the crystals aggregate because it's forming in a different place. So where the kidney stone forms takes on the shape of where it is. So free-forming ones form cylindrical type of shapes, whereas ones that are forming elsewhere in the kidneys and like maybe tucked away in a pocket or a nephron, they have a different shape to them. In any case, so we have all these concentric rings of crystals that are starting to form. But here's where it gets interesting. We start to see here over time that this dihydrate, the monohydrate, this actually starts to dissolve and becomes an empty void in the center. Now, it won't completely go away. In some instances it does, but this is why we see oftentimes a lot of mixed stone types where you have a dihydrate core with a hard exterior of calcium oxalate monohydrate on the outside. Sometimes it completely goes away and it is just a pure calcium oxalate monohydrate stone, but oftentimes we see these hybrid type of stones with a mix. So rings continue to build, they continue to build over time, and then at one point, and this is where we sometimes see those pure calcium oxalate monohydrate stones, all that goes away and it starts to get filled in by more calcium oxalate monohydrate. But we're calling this calcium oxalate monohydrate, let's see, what did I call that? Replacement COM. So we start to see this grow actually from the inside out. So we have a pure calcium oxalate monohydrate stone that is representing itself. So I don't know about you, but I find this just absolutely fascinating. And again, for me, the big things I want us to take away in terms of how do we prevent these types of stones based on what we know on how they form. So again, just to recap here, urine supersaturation. This is the start of any type of calcium oxalate monohydrate stone. So if we can address urine supersaturation, we can eliminate or severely slow down the process of calcium oxalate stones forming. And again, you can do this by eliminating dietary oxalates, increasing calcium intake, increasing your water intake, don't hold in your urine, but just overall being hydrated and eating less oxalate will help with this urine supersaturation. The other thing as well, when we start to take a look at these stones, when they're in their most susceptible stage, and that's really at this stage right here, when they start to get a whole bunch of rings of calcium oxalate monohydrate, that's when things get tough and it's really hard to attack this. But potassium citrate, introducing this into your diet can help you combat this type of kidney stone from forming. And that's why with our product Cleanse, we have naturally occurring potassium citrate, which is the most bioavailable source of potassium citrate from whole food and herbs that you can get. Your body recognizes it, it will use it. But oftentimes there are supplements out there that you can pick up at the pharmacy, or maybe there's some other brands out there as well that use synthetic potassium citrate. And you'll know that it's synthetic because it's just potassium citrate. It's just labeled as what it is. Our body doesn't recognize what this is and cannot use it to its full ability. And that's why it's so important to get potassium citrate from natural whole food sources that your body recognizes and can utilize. And this is a great advantage because you don't have to consume as much because your body is able to use it more efficiently. So if you're struggling with the kidney stone, think about hydration, dietary oxalates, and potentially introducing a supplement like Cleanse or potassium citrate to help fight these type of stones. So thank you very much for sticking around. I know this was a longer video. Please, if you have any comments or questions, please drop them below. We do respond to everything that you guys send to us, and we'll see you again in the next video. Thanks, everybody.